this here applies to any other object casting its shadow when placed next to the source of light. In this particular case, the source of light is the sun. The object casting the shadow is the moon, right? But I can have a light bulb and say a golf ball, and the same analysis would apply. So let us look at the types of shadow that the object casts. In principle, every point on the light source emits the light rays. So this point here, it will emit light in all possible directions, but this particular ray that just grazes the top of the moon, right, goes this way, and this one here, all the other rays between these two are going to be blocked by the moon. Right? And the same here, right? Any ray between these two rays is going to be blocked by the moon. So we do that point by point on the surface of the light source, and then we construct the type of the shadow that we can have. So if I'm anywhere between this top ray that is grazing the top of the moon and this ray here that is grazing the bottom of the moon, if I'm in this blackened region denoted by A, I cannot see the sun. In that case, I have the total eclipse. I will draw this again, but I just want to make the argument and then I'll repeat it again. However, if this region here of complete shadow is called also umbra. It's a Latin name for the complete shadow. Okay. Now, on the other hand, if I'm, say, located here, a lighter shaded region, if I'm located here, I can actually see the little bit of the top part of the sun. I cannot see the bottom part of the sun. Okay? So if I'm located here, this is what I see. Right? This region of partial shadow, either here or there, is called penumbra. So if you are located in the umbra, you are in a complete shadow, right? And you have the total eclipse of the light source. If you are located in partial shadow, either here or here, if I'm, say, the point C right there, now I can see the bottom part of the sun. I can see the top part of the sun, and this is what I see. So these two types of the eclipses are called partial eclipses. This one here is called the total eclipse. Okay? And now, if I'm far enough, if I'm located, say, here at D, I can see the outer rim of the sun. I cannot see the middle part. And such an eclipse, this is what one sees from point D, and that kind of eclipse is called annular eclipse, because you see the outer ring of the sun. Okay? So these are the types of the eclipses that one can have, and depending on where we are on Earth, whether we are in complete shadow, which is not very wide, at the Earth, the complete shadow is only 269 kilometers wide. Partial shadow is much wider. It's about 9,200 kilometers. Yeah? So if you are located in the complete shadow, in umbra, you will observe the total eclipse. In penumbra, partial shadow, you will see, one sees partial eclipse, and then at special locations, one can also observe the annular eclipse, I should say. Okay, so here is the light source, say the sun. And here is the body casting the shadow, say our moon. So then I start from the top edge of the sun, and I trace the two rays that graze the top and the bottom part of the moon. And then I start from the point on the light source that is at the lower edge. Again, I trace two rays that graze the top and the bottom of the obstacle. So here it says sun, and this here is moon. And in this region here, I have complete shadow, or umbra. Okay, and here I have partial shadow that I denote with the dots. And that is called penumbra. So, observer in umbra, he sees total eclipse. That is, the entire disk of the sun is blocked, and the only thing what you can see then is the sun's lower and atmosphere, so-called chromosphere, and the outer atmosphere, so-called corona. Now, an observer at 1 in penumbra, this guy will see the top portion of the sun, right? So what he sees is something like this. And that's partial eclipse. Observer at 2 would also see a part of the sun, but now the lower part of the sun, which is also partial eclipse. And an observer at 3 would see the outer edge of the sun, complete outer edge of the sun, a ring, right? And for that reason, such eclipse is called annular eclipse.